Hi everybody, welcome back. We are on the next section, the next part of section 5, Decimal 1, which is page 5. We're going to look at how to order irrational numbers. So obviously these cube root, these square root numbers are irrational numbers. They have a decimal that is non-repeating, non-terminating. So it says in the first question, example A, it says arrange in order from least to greatest without the use of a calculator. So obviously if you want to rearrange these in order from least to greatest, you just plug them in your calculator. So how you do show this without a calculator is you'll notice that you want to put them all in the same, have the same radicand basically. So basically the same number underneath the square root sign. So in order to do so, we have to convert each to an entire radical. So 5 as a radical is obviously the square root of 25, which I have below right here. 4 square root 2, remember we square the 4 and we get 16. 16 times multiplied by 2 is 32. And then we have 2 square root 6, so we square the 2 and we get 4. 4 times 6 is 24. And then we have 3 root 3, which is 3 squared is 9, and 9 multiplied by 3 is 27. So now we take these and we order them from least to greatest. So obviously the square root of 24 is the smallest, so 2 root 6 comes first. That should be a 6 right here. I will fix that right now. Sorry about that. So I have the 6 fixed now. Next, next lowest number, the second one would be the root square root of 25, which is simply 5. The next would be the square root of 27, which is 3 root 3, 3 square root of 3. And the largest number we have is the square root of 32, which is 4 root 2. So when you arrange irrational numbers from least to greatest, switch them into the same, either both being an entire radical. That's normally what we do with these because obviously if these were all had the same radicand, so the number underneath the square root sign, then we would obviously know which is more and which is not. So normally we change these into an entire radical. That's the easiest way to do this. Again, you could switch them to a decimal, but to show your work and get full points in a constructive response question where the work needs to be provided, this is how you would do it. Obviously, if this was a multiple choice, then it's obviously done differently or a different technique or a different strategy you may use, but when I always do questions as if they were a constructive response, and I think you should do that as well. That's how. So let's look at the example B. They're all negative, so the difference in this case is that, remember, the least number is going to be the number that has the greatest number underneath the square root, obviously because the negative out front, right? Because you're going in the left direction instead of the right. So think of it that way, maybe. So the smallest number will be the negative of the largest square root, obviously. So that's why these negative 3 root 5, when changed to the negative square root of 45, is the lowest number because it has the lowest value, right? It's like negative 8 is less than negative 1, if that makes sense. Okay? These can also be done with cube roots. So I'll do C with you. It says 3 cube root 4, so we'll cube 3. 3 cubed is 27, and 27 multiplied by 4 is 108. Okay? 4 cube root 2 means 4 multiplied by the cube root of 2, so we cube 4, and that's not the 3 there. The 3 is the index with the square root of 2. But we do cube the 4 to get 64, and 64 multiplied by 2 is 128. 2 cubed is 8, 8 times 5 is 40, and obviously this is already an entire radical, so we just leave it. So least to greatest would be 40, which is 2 cubed root 5, which is first. The next one would be the cube root 87, which is just rewritten as itself. Remember, you rewrite your originals back, not what you've changed, right? And 3 cubed root 4 is So the third largest, and the largest we have is this cube root of 128, which is 4 cube root. Okay, so they can be done with cube roots as well. Let's look at adding and subtracting radicals. So when we add and subtract radicals, we have to collect like terms. You're familiar with this. So you recall if we had 3x minus 2y plus x plus 4y, basically the variable has to be the same, completely the same, and that's the same as the radicals. We call these like radicals. So the 3 root 5 and plus root 5, we can add them together. So we rearrange them, and then we add 3 plus 1. There's a 1 here, we don't see it, but it's 4 root 5. And the negative 2 root 3 and the plus 4 root 3, we put them in order, and then we add them here. So negative 2 plus 4 is 2, and then we just carry the root 3, right? So basically, it's done the exact same way as you learned how to collect like terms when you started learning about adding and subtracting variables that were different, right? So x and y, the x's come together, the y's come together. Same deal. Like radicals, the square root of 5's come together, and the square root of 3's come together. They have to be identical. There can be nothing different underneath the square root sign in order to add them together. Okay? They have to be identical. So let's look at example 1. It says simplify the following. So simplify the following means adding together. So obviously in the first one there, they're all the square root of 6, so we just add the coefficients out front, right? It's as easy as that. So we would just take 7 and subtract 3, we get 4 root 6, and add root 6, which is 1 root 6, and we get 5 root 6. Example 1b, we have 2 like radicals. We have the root 3 and root 2. So the root 3 gets grouped together, so I just rearrange what I have here. So 2 root 3 minus 3 root 3, that's what I have here in the first step, minus root 2 plus 4 root 2, and sort of them together, I group them, I guess, right? And then we have 2 root 3 minus 3 root 3, so I have negative root 3, and I have root 2 plus 4 root 2, which gives me 3 root 2. And that's it. Nothing you can do with that. They can be added together, they're not like, it's like taking x and y and you're finished. You can't go any further. In example C, it's on the similar way. 2 root x minus 5 root y. So if we have variables underneath the square root, so the radicand's a variable, that's fine. We have like radicals, and the x's will be added together and the y's. So just be mindful of that. It's very important that they're the same. I know some of you are thinking, well, what happens when we can simplify? You guys are right on track, because that's what we're going after when we do these examples. So we can do it when we have fractions as the coefficient. We just have to find a common denominator. So we have a quarter and 2/3. The common denominator would obviously be 12, so 1/4 becomes 3/12. And the 2/3 here becomes 8/12. We add them together and we get 11/12, root 7. Okay? And this is what I know some of you were thinking already, because you guys are a very bright group. And what we do is we have entire radicals. So when we're trying to add entire radicals, we first must change them to the simplest form of the mixed radical. So as we know, square root of 27 can be written as 3 root 3. And I've shown the steps there. This step here is not necessary. I just wanted to show where it came from. This is what we learned to do in grade 10. So the square root of 27 is the same as 9 multiplied by 3, which is underneath the square root, of course, which would be square root of 9, which is 3, and 3. Okay? And 32 becomes 16 multiplied by 2, which is 4 root 2. 4 becomes, the square root of 4 becomes 2, and the square root of 25 becomes 5. And then we can add the square root of 3's together. 3 subtract 2 would be 1 root 3, and then 4 root 2 plus 5 root 2 is 9 root 2. So the final answer is the square root of 3 plus 9 multiplied by the square root That's it. Nothing else you can do with that unless you were to find a decimal and add them together. But we don't like decimals anymore, as you guys recall. Okay, so you can do them that way. Example 2, simplify the following. You have the square root of 24 plus the square root of 54. The square root of 24 can be written as 2 root 6, and the square root of 54 can be written as 3 root 6. So I know I'm skipping steps here, but this stuff here is grade 10. Okay? This is new when we actually had them together, right? And I did a little bit of this with you. If you took Math 10 Pre, we did a little bit of this last year, adding them together as an extra. If you do recall, you get 5 root 6. But I think you guys wouldn't have done the simplifying part. Maybe you did it all together. I'm not sure. I don't remember. Not a big deal. The next one, we have 6 root 45 minus 5. So we already have them as mixed radicals, but they can be further broken down because 45 can be written as 9 multiplied by 5, as you're aware, right? And 45 is factors of 9 and 5, and 9 is a perfect square, so 9, we take the square root of 9 and we get 3, and that becomes a coefficient up front. And 3 gets multiplied by the 6, and we get 18 5. So 6 root 45 is equivalent to 18 root 5, and you want to make sure that all you do is you take your graphic calculator out, or sorry, just your calculator, and you just check that, right? Just to double check. Never hurts. So what I mentioned earlier there, I think it's a good opportunity to try to check your work, right? So I just want to take an example. Example here. I wanted to show you that 6 root 45 is equal to 18 5. I think that's important. So we have 6 square root of 45. Just hit enter, and you get 40 decimal 4, blah blah blah. And do the same thing with 18 square root of 5, and you can enter, and they're obviously the same, right? So that's just a way to do a quick check to make sure you're doing it correctly. I think I showed that in the previous video, but definitely a good opportunity to take a look and check that out. Okay. And then obviously 5 root square root of 80 is the same thing. The square root of 80 broken down to 16 root 5. The square root of 16 becomes 4. 4 times 5 is sort of negative 5 is negative 20. 5, and then these are like radicals, so now we can add them together and get negative 2. So to double check this again, if you wanted to make sure it's correct, you just add these together here on your page and do the same to make sure this is equal. So I'll do that right now with you. So we have 6 square root of 45. Subtract, take a look at 5 square root of 80. Right, we get enter, and we get negative 4 decimal 47 dot. So we go down and we take this to check it. Negative 2 root 5. It should give us back the same. So negative 2 square root of 5, and we should get the exact same item. Correct there. My apologies. And we do. Alright, just a quick check, make sure you're right, and it doesn't hurt. Okay. And the last one on page 7 here, and then we'll pick up a little later. Yeah, let's just do the last one. We're coming up on the 15-minute mark. So now this time we just have 4 radicals, right? We have a mixture. We have some entire radicals, some mixed radicals. Some mixed radicals we broke it down more, so just be mindful of that. 98. You guys think probably with your mental math. Remember, we got 49 times 2, so square root of 49 is 7. 7 times 14. Right? Square root of 10 can't be broken up anymore. It doesn't have any more perfect square factors. 8 can be 2 root 2. Multiplied by 5 you get there. And then 40 can be 4 and 10. So 4 times 10. So then we have 2 like radicals of 10. 2 like radicals with the root of 2. Add them together. And okay. So we only have 20 seconds left with this, so we'll pick it up on page 8 for 5 decimal 1 in the next video. Thank you, everyone, and we'll see you soon.